Exercise 10.2. Exercise 10.2 of vector algebra. Okay. Exercise 10.2 of the vector algebra. So first point is addition of vectors. Addition of vectors. Addition of vectors. Addition of vectors. How we will find the addition of vectors? Addition of vector means by triangle law of addition, if say this is, suppose this is triangle ABC, okay, ABC, so this is AB and this is BC, okay. So as per triangle law of addition, addition vector means AB vector plus BC vector is equals to AC vector. AB vector plus BC vector is equals to AC vector as per triangle law of addition. Okay, so this is known as triangle law of addition. Okay, and now the few properties are there. So the properties are, again the vectors are commutative. Properties of, so vector A plus vector B is same as vector B plus vector A, which is called commutative law. Commutative law. Okay, जैसे in simple algebra 2 plus 3 is same as 3 plus 2. So similarly in the same case, vector A plus B is equals to vector B plus A. It is called commutative property or commutative law. Okay, then associative property. Law or property, whatever you want to write, you may write commutative property. Okay, then next is property, and the next is vector A plus vector B plus vector C is equals to vector A plus vector B and plus vector C. This is called associative property. Associative property. Or in simple language or in simple algebra, we can say that 2 plus 3 plus 5 is same as 5 plus 3 plus 2. Okay. Then the next property is the vector A plus 0 vector same as 0 vector plus A vector is equals to A vector. Okay. Means 0 plus 2 or 2 plus 0, we will get the same answer 2. So similarly in the case of when 0 vector is added to any vector or any vector is added to 0 vector, we will get the remain same vector, and this is called additive identity. Additive identity. Okay, this is called additive identity. Okay. Now, multiplication of a vector by a scalar. So, multiplication of a vector by a scalar means multiplication of a vector by a scalar. Okay. So, means what does it means? Okay, let A be a given vector and lambda be any scalar vector. So the product of vector A by the scalar lambda is denoted by lambda A vector. Okay, lambda A vector, where lambda is any scalar and A is any vector, and the product is means the scalar is multiplied with the vector. This is denoted by lambda A vector. Okay. So the magnitude of vector A means if we will find the magnitude of lambda times A vector is equals to magnitude of the lambda into magnitude of A vector. Okay, got it? And unit vector, as I get given you formula for the unit vector, how we will find a unit vector? So unit vector is denoted by A cap okay, and a cap is equals to vector upon magnitude itself, vector upon magnitude itself, okay. Now the next point is component of vectors. Component of vectors. Component component of vector. So every vector, suppose the vector A is xi cap plus yj cap plus zk cap. This is any vector. So this xyz, these are called a scalar component, a scalar component, okay. And this I, J and K, this is called vector component, okay, vector component, okay, got it? Okay, so keeping these concepts, now move to the exercise. But before going to the exercise, next is vector joining the 2 points. If the 2 points are given, then how we will find the vector? Vector joining 2 points, okay, vector joining 2 points. So let, if P is having a point x1, y1 and z1, and Q is another point whose coordinates are x2, y2 and z2. So how we will find the vector? So vector is equals to, vector PQ is equals to, this is x2 minus x1 I cap, okay, plus y2 minus y1 j cap plus z2 minus z1 k cap. So this is the formula to find the vector if 2 points are given, okay, if 2 points are given. Now the next is the section formula, the section formula, okay, section formula. So as we read in the coordinate geometry in class 10th, or in the case of 2D and in the case of 3D in class 11th, okay. So we will apply the same concept here. We will apply the same concept, section formula, okay, section formula. So how we will find a section formula? If the points divide internally, or the point may be divide externally, okay. So if the point divides internally, so R vector is equals to M B vector plus N A vector upon sum of the ratio M plus N. Okay, sum of the ratio M plus N. So this is called internal division. Internally, if the point is divided, the point, suppose this is A vector and this is B vector, which divided by a point P in the ratio of M is to N, internal division. So that is M, formula is M B vector plus N A vector upon sum of the ratio, that is, this is called internally form division. In the case of externally, if the points, this point divides externally, so in the case of externally, so this R vector is equals to M B vector minus N A vector upon M minus N. So this is external division, okay. So if the question says this point divides internally, if the two vectors are given, we will apply this formula to find the required vector, and if the point divides externally, then we will apply MB vector minus NA vector upon M minus N. And the last thing, the last concept is midpoint formula. Midpoint, okay. So if the two vectors are given, then midpoint will be equal to vector A plus vector B divided by 2. Okay, just like as you read in the class 10, x1 plus x2 by 2 or y1 plus y2 by 2. So same in the concept in the vector case. So if two vectors are given, then sum of the vectors divided by 2, whatever the value will obtain, that is the midpoint of the vector. Okay. So by keeping this concept, now we will switch over to the exercise, okay, of your book. The very first question is compute the magnitude of the following vectors. The very first question. Okay. Let me erase, then we will start solution question wise. So we will start exercise 10.2. Okay. The very first question of exercise 10.2, the question says compute the magnitude of the following vectors. Vectors are given. Okay. So vector A is equals to I, vector A is equals to I cap plus j cap plus k cap. So how we will find the magnitude of this vector is equals to root over of the square of the scalar component, that is 1 square plus 1 square plus 1 square, and this is equals to root 3. Okay, this is equals to root 3. Find compute the magnitude of the following vectors. Then the second part is given, vector B is equals to 2i cap minus 7j cap. Okay, 2i cap minus 7j cap and minus 3k cap. So we will find the magnitude of this vector is equals to a square of 2a square and a square of minus 7a square and plus minus 3a square. Okay, so this will be equal to 4 plus 49 plus 9. So 49 plus 9, 58 plus 4, that is root over of 62. Okay, so in this way we will find the magnitude of any vector, and the C part I am leaving for you. You will complete yourself. Okay, now the next question is question number 2. The question number 2 is write the two different vectors having the same magnitude. Okay, so we have to write the example, two different vectors. Let vector A is equals to I cap minus 2j cap, okay, and plus 3k cap. This is vector A. And what about the magnitude? 9 plus 4, 13 plus 1, 14. So vector B we can write, just change the direction. This is 2i cap and then plus j cap and then minus 3k cap. Okay, just you may write any example, any vector, okay, and then change its direction, change the sign, then we will get the same magnitude, because its magnitude will be a square root of 1 plus a square root minus 4 square whole square plus 3 square, 9, 4, 13, 14, and again here you will get 4 plus 1 plus 9, magnitude is same. So in this way you can give a lot of examples. Now the third question is write two vectors having the same direction. So let vector P is say I cap plus j cap and plus 3k cap, and take another vector Q that is equals to 2i cap plus 2j cap plus 6k cap. So what you can do, write any vector as you like, and then for the second vector you can multiply by any scalar number, but all the components multiplied by the same number. Okay, if you are multiplying by 2, then it will be 2i cap plus 2j cap plus 6k cap. If you are multiplying by 4, then it will be 4i cap plus 4j cap plus 12k cap. Okay, so in this way we can write a lot of examples. Then the next question is question number 4. Question number 4. And the fourth question is, find the value of x and y if the two vectors are given. Okay, question number 4. The two vectors are given. Two given vectors are 2y cap plus 3j cap and xi cap plus yj cap plus yj cap plus yj cap. Okay, this is the question, are equal. Means according to the question, 2i cap plus 3j cap is equals to xi cap plus yj cap, and we have to find the value of x and y. So by equating, this is the scalar vector component I cap and I cap, so the value of x is equals to 2 and the value of y is equals to 3, and this is the answer of this question number 4. Okay, now the next question is question number 5, and the fifth question is, find the scalar and vector component of the vector with the initial point 2 1 and terminal point minus. So if the point P is, say it is 2 1 and next point is Q, this is minus 5 7. So we have to find the vector PQ. So by applying the formula, by joining 2 points vector means x2 minus x1, x2 minus x1, okay, I cap plus y2 minus y1 j cap. So x2 minus x1 means minus 5 minus 2 I cap and plus 7 minus 1 j cap. So finally it is minus 7 I cap and plus 6 j cap. Okay, so that will be the, this is the vector, and we have to require the scalar component. So scalar components are minus 7 and 6. These are the scalar components. Okay, and vector components. So vector components are minus 7 I cap and 6 j cap. These are the vector component. Okay, then the next question is question number 6. Question number 6, and the sixth question is, find the sum of the vectors. Means all three vectors are given. Vector A is given. Vector A is equals to I cap minus 2j cap and plus k cap, and vector B is given. Vector B is given minus 2i cap and plus 4j cap and plus 5k cap, and vector C is given. Vector C is equals to I cap minus 6j cap, okay, and minus 7k cap. Then question says find the value of A plus B plus C. Okay, means the vector components will be added or subtracted to the same. So here I cap 2 I cap minus 2 I cap, that is equals to 0 I cap we can write, and minus 6j and minus 2 minus 8j plus 4j, that is equals to minus 4j cap, and 5k cap plus 1k cap, that is 6k cap, and this is minus 7, so it will be minus k cap. So the final answer is minus 4j cap and minus k cap. This is the value of A plus B plus C. So either you may write up to here or up to right here. So it is up to you. Okay, got it? So the next question is question number 7. Question number 7. So the seventh question is question number 7. And the seventh question is find a unit vector in the direction of the given vector. So vector A is given. Vector A is equals to I plus J and plus 2k, and we have to find the unit vector. So as per the definition of the unit vector, A cap is equals to vector upon magnitude itself. So vector is I cap plus j cap plus 2k cap divided by what about the magnitude? Square of 1 plus square of 1 plus square of 2. So this is I cap plus j cap plus 2k cap divided by root over 2 square 4 plus 5 plus 1 6, that is root over 6. So finally we can write 1 by root 6 I cap and 1 by root 6 j cap and 2 by root 6 k cap. Okay, so this is the answer of this question number 7. Okay, now the next question is question number 7 that we have already taken. Now the question number 8, find a unit vector in the direction of the vector PQ where P and Q are the points. P points are given. Okay, so point P is given. Point P is given 1, 2, 3, and point Q is given 4, 5, 6. Okay, 4, 5, 6. So first we will find the vector PQ by applying vector joining 2 points x2 minus x1. So 4 minus 1, that is 3i cap, and 5 minus 2, that is 3j cap, and 6 minus 3, that is 3, so plus 3k cap. So this is the vector. Okay, and now find the unit vector of this PQ. So vector PQ upon magnitude of PQ. Okay, so vector PQ is equals to 3i cap plus 3j cap plus 3k cap and divided by root over 3 square 9 plus 9 plus 9. So that is 9 into 3. So 3i cap 3i cap plus 3j cap plus 3k cap and divided by root over 27, and root over 27 means 3 root 3. So this is 3i cap upon 3 root 3 plus 3j cap upon 3 root 3 and plus 3k cap upon 3 root 3. So we can cancel this 3. So what is left? 1 by root 3 I cap plus 1 by root 3 j cap plus 1 by root 3 k cap. So this is the final answer of this question number 8. Okay. Now the next question is question number 9. And the ninth question is question number 9. Okay. And the ninth question says for the given vectors A and B, find the unit vector in the direction of A plus B. Means, what does it mean? Okay, first we will find the value of A plus B and then we will find its unit vector. So here vector A is given. A is equals to, this is 2i cap minus j cap plus 2k cap, and B vector is given. B vector is equals to minus I cap plus j cap and plus k cap. We have to find the unit vector in the direction of a plus b. So first we will find a plus b. So 2 cap and minus I cap, that is equals to I cap, minus j cap plus j cap cancel out 0. Okay, it will be 0, and plus 2 and plus 1, that is equals to 3 k cap. So this is the sum. So suppose it is, let it is vector c. Okay, so the unit vector of c is equals to vector c upon magnitude of c. So the vector c is I cap plus 3k cap divided by root over of 1 square plus 3 square. So that is root over 10. So 1 by under root 10 I cap. Okay, I cap, and there is no j cap. So it will be 3 by root 10 k cap. So this is the final answer of a plus the therefore, or you may write okay, therefore the unit vector of a plus b, the unit vector of a plus b is equals to 1 by root over 10 I cap plus 3 by root over 10 k cap, and this should be the uh, let me check here, it is minus k cap. Okay, here it is minus k cap in the question. I have written wrong. Minus I cap plus j cap and minus k cap. So of course this will be change. Okay, this will be change. This will be changed. So vector A plus vector B is equals to 2i minus I, that is I cap. Okay, and minus j plus j, this is 0, and 2k plus minus k, that is plus k cap. Okay, so the unit vector of a plus b, so it is equal to vector c. We can let it. Okay, suppose it is vector c, so the c cap is equals to vector c upon magnitude of c vector. So c vector is equals to I cap plus k cap divided by root over of 1 square plus 1 square. So finally it is 1 by root 2 I cap and plus 1 by root 2 k cap. Okay. So therefore the unit vector of a plus b, the unit vector of a plus b is equals to 1 by root 2 I cap plus 1 by root 2 k cap, and this is the final answer. Okay, now the next question is question number 10, and the 10th question is find a vector in the direction of 5 I cap minus j cap plus 2 k cap which has magnitude 8 units. Magnitude is given. Okay, so what is the vector? So let vector A is given, this is given, let vector A is equals to 5 cap, 5 cap and minus j cap plus 2k cap. This is the given vector and its magnitude is 8. Okay, so first of all we will find the magnitude of this vector. So this is 5 square 25 minus 1 square 1, and this is 2 square 4. So it will be equal to root over of 30. Okay, root over of 30. Then write the formula. So unit vector is equals to vector upon magnitude itself. This is the formula, and now it is equals to 5 I cap minus j cap plus 2k cap divided by root over of 30. Okay, and it has 8 magnitudes. So according to question, it has 8 magnitudes. So 8 a cap is equals to 5 I cap minus j cap plus 2k cap upon root over of 30. Okay, So this can be written as, so multiplied by 8 on both the sides. So 8 a cap is equals to 8 times multiplied by both the sides. So this will be 8 5s are 40 by root 30 I cap minus 8 j, 8 by root 30 j cap, and plus 8 to the 16 by root 30 k cap. Okay, so this should be the answer of this question number 10. Okay, now the question number 11. Question number 11 is, show that, question number 11, show that these vectors are collinear vectors. Okay, this is the question. Question number 11. Question number 11. Show that the vectors 2i cap minus 3j cap plus 4k cap and minus 4i cap plus 6j cap minus 8k cap are collinear. Okay, so let this given vector, suppose a vector is equals to 2i cap minus 3j cap and plus 4k cap, and the another vector, suppose it is b, and b vector is minus 4i cap and plus 6j cap and minus 8k cap. Okay, so now in the b vector some scalar number is coming common, so can we take minus 2 as common? So now it is 2i cap and minus 3j cap and plus 4k cap. So now the vector a and vector b, okay, it is coming with a scalar number. So this is equals to minus twice of vector a, and so this implies that, what does it mean? This implies that b vector is equals to lambda times a vector. Okay, where lambda is equals to minus 2, we can write this is the scalar number, lambda is minus 2. So therefore hence vector a and vector b and are collinear. Okay, this is the collinear. So this is the process to simplify. A is given, b is given, so some minus 2 a scalar number that is coming common in vector b. So after taking the common, now this is equal to a vector a, so this minus 2 is a scalar number, so we can write b vector is equals to lambda times a vector. So therefore it is, the given vectors are collinear. Okay, now the next question number 12, and the question number 12 is, find the direction cosines. Direction cosines. Question number 12. And the 12th question is, find the direction cosine of the given vector. Let given vector A is I cap plus 2j cap plus 3k cap. So in this given vector, we have to find the direction cosines. Okay, so first of all, we will find the magnitude of this vector. So magnitude of this vector is equals to a square of 1 1, a square of 2 4, a square of 3 9. So this is equals to root over of 14. Okay, so unit vector is equals to 1 by root 14 I cap plus 2 by root 14 j cap plus 3 by root 14 k cap. This is the value of this unit vector. Okay, so the direction cosines are, therefore the direction cosines are what are the direction cosines in this case? So this is 1 by root over 14 and 2 by root over 14 and 3 by root over 14. So these are the direction cosines of this given vector. Okay, so next question is, question number 13. And the 13th question is find the direction cosine of the vector joining this and this directed from A to B. So A point is given and B point is given. Point A is 1, 2 and minus 3, 1, 2 and minus 3. And point B is given minus 1, 2, minus 2 and 1. These are the points. So first of all, we will find the AB vector because as per the question, directed A to B. So AB vector by applying the formula x2 minus x1 I cap, okay, and y2 minus y1 j cap plus z2 minus z1 k cap. So minus 1 that is equals to minus 2 I cap, and minus 2 and minus 2 this is minus 4 j cap, and 1 and plus 3 4 this is equal to 4k cap. So this is the value of vector AB. Okay, so now magnitude unit vector of AB is equals to vector AB upon magnitude of vector AB. So this is 2i minus 2i cap minus 4j cap plus 4k cap divided by what about the magnitude? Square of minus 2 4, square of minus 4 that is 16, square of 4 that is 16, 32 plus 4 36. So this is equals to minus 2i cap upon 6 and minus 4j cap upon 6 and plus 4k cap upon 6. So finally we can write minus 1 by 3 I cap and minus 2 by 3 j cap and plus 2 by 3 k cap. And now the question says find the direction cosines. So therefore direction cosines are minus 1 by 3, minus 2 by 3 and minus plus 2 by 3. So these are the direction cosines of this vector AB. Okay. Now the next question is question number 14. The 14th question. And the question number 14 is show that the vector I plus j plus k, the given vector are equally inclined. Okay, so vector given vector is A is equals to I plus j plus k, and we have to show that they are equally inclined. So first of all, what we have to do, find their direction cosines, and direction cosines will remain same. So first of all, we will find the its unit vector, okay, or then find the magnitude first, then we will find the unit. So magnitude of this vector is equals to 1 square of 1 plus a square of 1 plus a square of 1 that is equals to root over 3. Then the unit vector is equals to vector upon magnitude itself. Okay, so this is 1 by root 3 I cap plus 1 by root 3 j cap plus 1 by root 3 k cap. Okay, so direction cosines equally inclined. So direction cosines are DCS are this is 1 by root 3 and 1 by root 3 and 1 by root 3. So direction cosines means cos alpha, cos beta, cos gamma. Cos alpha 1 by root 3, cos beta also 1 by root 3 and cos gamma also 1 by root 3. It means they are equally inclined. Okay, so this implies that they are equally inclined. Okay, equally inclined. So this is your question number 13. 14th. Now the next question is find the position vector of R which divides the line joining the 2 points P and Q. The two vectors are given, first in the case of internally and second in the case of externally. Okay, so just by applying the formula for the internal division, that is MB vector plus NA vector upon M plus N, and for external division MB vector minus NA vector upon M minus N. Okay, So question number 15. And the 15th question is for the internal division. Here the two vectors are given. Okay. So one vector A is vector A is given I cap plus 2j cap minus k cap, and this B vector is, suppose it is given minus I cap plus j cap and plus k cap are divided, and the given ratio is given 2 is to 1. Ratio is 2 is to 1. So for the internally, first of all we will apply the formula for the internal division. Internally is equals to m b vector plus n a vector upon m plus n. So mb vector, what is m? This is m or this is n. So 2 into minus I cap plus j cap plus k cap and plus n. N is 1. 1 into I cap plus 2j cap minus k cap. Okay. Divided by sum of the ratio 2 plus 1. And now simplify it. So this is minus 2I cap minus 2I cap plus 2j cap plus 2k cap and plus I cap plus 2j cap and minus k cap upon 3. So minus 2I cap plus 1I cap, that is minus I cap, 2j plus 2j, that is 4j cap, and 2k minus k, that is plus k cap, divided by 3. So this is the required vector, okay, for internal division. Similarly, you can find externally. So for externally, that is mb vector minus na vector upon m minus n. Now I am leaving for yourself. You will complete in the same way, but only the difference is here is minus. Okay, then you will calculate. Now the next question is question number 16. Question number 16. The 16th question. Question number 16. And the 16th question is find a position vector of the midpoint of joining these two vectors. Okay. So midpointing position vector is given. So vector P is equals to 2I cap. The point is already given. The position of the point is given 2I cap plus 3j cap and plus 4k cap. Okay. 4k cap. And another vector Q is given. So this is 4I cap and plus j cap and minus 2k cap, and we have to find the position vector of the midpoint. Okay, let R be the midpoint. So the midpoint of this vector is equals to midpoint. Okay, midpoint, find the position vector of the midpoint. So write down the position vector of midpoint of P and Q. Vector P and Q is equals to vector P plus vector Q divided by 2. So 2I cap plus 3j cap plus 4k cap and plus 4I cap plus j cap minus 2k cap divided by 2. So 2I and 4I. Okay, 2I and 4I, that is equals to 6I cap and 3j plus 1j, that is 4j cap, and 4k minus 2k, that is plus 2k cap, divided by 2. So take 2 as common. So it is 3I cap plus 2j cap and plus k cap divided by 2. So this is cancelled. So the final answer should be 3i cap plus 2j cap plus k cap. This is the required vector. Okay. And now the question number 17th. And the 17th question is, show that the points A, B, C with the position vector A, B and C vector are respectively form the vertices of right angle triangle. Vertices of right angle triangles means by applying the Pythagoras theorem, means a square of the any one side should be equal to sum of the square of other two sides. So in the case of vector, we will find the position vector of these 3 points A, B, C, and then we will find its magnitude, and the square of the magnitude is equals to sum of the square of magnitude of other two vectors. Then it is right angle triangle. Okay, so position vectors are given. Okay, OA is equals to vector A. This is given. So question number 17, where so it want a space, so I will simplify here. Question number 17. Question number 17. Okay. So position vectors of A, B, and C. That is, A is equals to vector A is given 3i cap minus 4j cap. So we can write OA. OA is equals to vector A, and this is given 3i cap minus 4j cap and minus 4k cap. Okay, and position vectors of B, that is B vector, and it is given B is equals to 2i cap minus j cap plus k cap, and position vector of OC, that is C, and it is also given C vector is equals to i cap minus 3j cap and minus 5k cap. This is given. Okay, so first of all, find the vector AB. Vector AB means this is A vector, this is B vector, so it should be B minus A, OB minus OA, OB minus OA. So OB minus OA, 2i minus 3i, that is equals to minus I cap, and minus j and minus minus plus 4j, so it should be plus 3j cap, and plus k and minus minus plus, so it will be 5k cap. Okay, this is the magnitude of AB. Then BC. BC means C minus B, OC minus OB. So OC minus OB means 1 minus 2, that is minus I cap, minus 3 and plus 1, so it is minus 2j cap, and minus 5 and minus 1, so it is minus 6k cap, right? And then CA. CA means OA minus OC. OA minus OC. That is A minus C. So 3i minus I, that is 2i cap, 2i cap, and minus 4 and plus 3. So that will be equal to minus j cap, and minus 4 and plus 5, that is plus k cap. This is the AC. Okay, see the vector CA. And now find the magnitude of AB. So this is equals to root over of 1 plus 9 plus 25, that is root over of 35. Okay, So therefore, the magnitude of AB square is equals to 35. And now find the magnitude of BC. And magnitude of BC is equals to 1 plus 4 plus 36. That is 41. So magnitude of BC square is equals to 41. And now find the magnitude of CA. And this is equals to 4 plus 1 plus 1, that is root over of 6. So therefore magnitude of CA square is equals to 6. And since magnitude of AB square, because 35 plus 6 is coming 41, so AB square plus CA square, okay, is equals to magnitude of BC square. So what does it mean? So it means that triangle ABC is a right angled triangle. And what about the right angle? Right angle at A. Okay, right angle triangle with right angle A. Okay, got it. And the question number 18. This is the MCQ question. In triangle ABC, which of the following is not true? So not true. AB plus BC, as per the figure, AB plus BC, it should be equal to AC. So we will write CA means minus CA, then we will transfer to the left hand side plus CA. So the first part is true. Okay, and B part is AB plus BC minus AC. So as per the triangle of addition, AB plus BC should be equal to AC. And if you will transfer this AC to the left hand side, so it should be minus AC. So the second part is also true. Now AB plus BC is equals to AC, and if you will transfer, then it will be minus CA, but here it is given, sorry, minus AC, but here it is given minus CA. So this is not true. Okay, so the C is the correct answer. Now the 19th question is again MCQ question. If A and B are two collinear vectors, then which of the following are incorrect? Vector B is equals to lambda times A vector for some scalar of lambda, it is true. Vector A is equals to plus minus B vector, again it is true. Okay, and the third part is the C, the respective components of A and B are not, are proportional, are proportional. Okay, so this is also are proportional. It should be, because the vector both and A and B have the same direction but different magnitude. This is also correct. So C is the correct option, is C. Okay, so this is all about your exercise 10.2. Thank you very much. If you have liked my video, please press the like button and share this link to your friends and ask them to join my channel so you will get the notification on time. Okay, thank you very much.